Hello everyone, welcome back to my YouTube channel Learning with Deepu. In today's video, I'll be discussing the topics of analysis design of algorithm. The topic is dynamic programming, exploring key concepts and applications in algorithm design. Introduction. Introduction to dynamic programming. Definitions and principles. Dynamic programming is a method used for solving complex problems by breaking them down into simpler subproblems. It is applicable when the subproblems are overlapping, meaning the same subproblems are solved multiple times. Learning problem is distinct from other algorithmic approaches due to its focus on storing solutions to subproblems to avoid redundant computations. Applicability in algorithms. Dynamic programming is widely applicable in many fields, including computer science, engineering, and businesses. It is particularly useful for optimizing problems where it helps us to find best solutions among the possible solutions. Examples include problems related to resources allocation, scheduling, and data compression when efficient solutions are necessary. Key concepts. Optimal substructure refers to the property that an optimal solution can be constructed from an optimal solution of its problems. Dynamic programming exploits these characters to build up solutions to large problems based on optimal solutions to the consequent subproblems. Memorization versus tabulation. Memorization and tabulations are two strategies used in dynamic programming to store subproblem solutions. Memorization is a top-down approach where two solutions are stored as recursive calls are made, by tabulation is a bottom-up approach that solves all possible subproblems iteratively and stores the results in a table. Common algorithms. Maps are problem. The problem is a well-known optimization problem where the objective is to maximize the total value of items placed in a knapsack without exceeding its weight capacity. The dynamic programming approach to this problem involves creating a table where each entry represents Dynamic programming approach to this problem involves creating a table where each entry represents the maximum value that can be achieved with a certain weight limit. It efficiently computes the optimal selection of items by considering combinations and ensuring that computational resources are used judicially. Shortest path algorithms. Dynamic program always plays a critical role in finding the shortest path in graphs. Algorithms such as Dijikra's and Floyd-Warshaw's algorithm utilize dynamic programming principle to effectively solve the problem of shortest paths by systematically exploring the paths and storing the minimal distance between nodes. These algorithms significantly reduce computations time and resources usage compared to naive methods. Analysis techniques. Time complexity analysis. Dynamic programming algorithm typically exhibit polynomial time complexity when compared to their naive recursive counterparts. The time complexity largely depends on the number of subproblems that need to be solved, which can be calculated based on input size and subproblem dependencies. Understanding time complexity is crucial for evaluating algorithm efficiency, especially for large inputs. Comparison with other paradigms, dynamic programming is frequently compared with algorithmic paradigms such as greedy algorithm and divide and conquer. While greedy algorithm make locally optimal choices with the hope of finding a global optimum, dynamic programming evaluates potential solutions to ensure understanding the differences is essential for selecting the right algorithm on the problem on the hand. Real world applications. Optimal control problems. Dynamic program is instrumental in solving control problems, facilitating strategic decision making to minimize cost and maximize benefits over time. Machine learning and AI. Dynamic program is crucial in machine learning and AI, enabling the optimization and enhancing strategy development in reinforcement learning applications. Dynamic programming effectively streamlines problem solving by breaking complex issues into manageable subproblems, enhancing the efficiency in various applications. Thank you for watching my video. See you in the next video.